Okay, Bismillahirrahmanirrahim. So today we're going to start with a new topic. It is topic 24. In the older syllabus, this topic would come under topic 6, but it is the A2 content. Okay. So the first part is something that I think you have come across this already. Predict the identities of substances liberated during electrolysis. So liberated means given off from the state of electrolyte, whether it's molten or aqueous, depending on a few factors, which is the position in the redox series, or this year in A-level, we're going to look at the electrode potential. I think previously you guys would have memorized it using the reactivity series. And concentration. Okay. So we'll just do a little bit of recap on what electrolysis is. Electrolysis is the decomposition of a compound into its element. So usually we use electrolysis to collect an element on the electrode, whether it's in a solid form or in a gas state. Using bypassing electric current. Okay, so we use direct current. In the process, the current is passed through the electrolyte, usually ionic compound in solution or molten state. So if you have it in solution, that means aqueous, you would have water, H2O. Just to remind you that H2O can also release a little bit or a small amount of H plus and OH minus. Okay. Is this 4.1? It's not 4.1, it's 5.1. Lim is having problem joining. Okay. Thank you, Wia. The electrodes, which is something that you already know, and I always forget. The positive electrode is called the anode. The positive terminal is called the anode, and the anode is connected to the positive terminal of the power supply. And the negative electrode is the cathode, which is attached to the negative terminal or the negative part of the power supply. Okay, so when using electrodes, there are two things: using the inert electrode, where it's important to understand that the inert electrode will not be affected, okay, in the electrolysis process. If you use a non-inert electrode, or what we call a reactive electrode, then it actually affects the selectivity of discharge. So I will talk about the selective discharge shortly. Okay, so electrolyte is a solution or molten compound which conducts electricity. Usually for electrolysis, what the electrodes do is that if you have, say, more than one anion or one cation,
Can you figure?
the electrode will only choose one to be discharged. Okay, so this is what we mean by selective discharge. Between sodium ions and hydrogen ions, according to the easiness, okay, the easiness of the ion to be discharged, H plus will be discharged on the, sorry, not anode, the other one, on the cathode. Okay, likewise, if you have OH minus and Cl minus in the solution, you have to check which one is easier to be discharged. In this case, which one is easier to be oxidized. That will be selected to be oxidized by the anode. Okay, that's all still familiar to you, right? I don't know how much you remember from your O-level syllabus. Okay. So this is what we mean by selective discharge, which ion is being chosen by that electrode. So before I look at this example, question 1.1, I will move on to page 2. If you have the soft copy of the notes, we will jump to page 2 first, and page 2 will be the factors. Okay, so you don't have to worry about printing out your notes because I have already printed it out, and it's in school. So depending on when I am able to get back, otherwise I will just ask someone, one of the chemistry tutors, to distribute the notes to you. Okay, right. So this is now on page 2 of your notes. The factors affecting selective discharge during electrolysis. The first one is the position of ions in the electrochemical series. This is the one I believe that you have to memorize last year, the reactivity series. But in A level, we're going to look at the what we call the electrode potential value. This electrode potential value is labeled, or the symbol is what we call E note. Okay. Now, if you have your data booklet near you, can you please take them? Your E note values would be on page 78. Okay. So I want you to be familiar with this data and how you read them. Okay, so if you have your data booklet, or if you have a soft copy of the data booklet, that's fine too. Okay, so it's on page 78 or page 80, whichever that is, but on the document it says page 78. Okay, so what you have here is a list of half equations. They are called half equations because the electrons are shown. You have come across half equation in your AS syllabus. Okay, now your E note values are these numbers. It comes in positive value and negative values. The way that your half equations are written, if you notice that the electrons are on the left side, which indicates you gain in electrons. It's a reduction equation. Notice that it's a reversible arrow, so the forward reaction is a reduction process because you gain electrons, and the reverse reaction is oxidation because you release electrons. Okay, and the numbers represent forward to be positive 0.80, and the reverse, the oxidation process, will be negative 0.80. Okay, so you just swap the sign depending on which reaction you are looking at. Forward reaction will be the same one as listed on your data booklet, but if you're looking at the oxidation, then you just change the sign. Okay, right. Sorry. So cation with the most positive electrodes will be discharged first. Now, cation tends to undergo reduction process. Okay, red cat. If you remember, cathode, on the cathode electrode, reduction happens. So your cathode is your negative terminal. So your positive ions will be attracted to the cathode. And what it means by positive number is that it favors the forward reaction. Okay, a negative number, negative E note, indicates that it favors the reverse reaction. So just remember, positive, you go forward, negative, you go backwards. So because the forward reaction is a reduction process, that means a positive E note means they are more likely to be reduced, whereas a negative E note means they are more likely to be oxidized. They favor the reverse reaction. For example, here, aluminium 3 plus to be reduced to aluminium because it has a negative E node. That means it is likely to go in the backwards reaction. Aluminium is more likely to be oxidized to aluminium 3 plus. Okay, so cation with the most positive E node will be discharged first. And for anions, it is the one with the most negative E node is discharged first. Okay, so it's just the opposite. I would highlight cation most positive because it means that the E node is most likely to be reduced, whereas your anion is the most negative, which means that it is most likely to be oxidized. Okay. Right. The second factor is the relative concentration of ions. For obvious reason, ions of higher concentration will be selected for discharge. And lastly, the nature of your electrode, where it matters if you use inert versus non-inert. Sometimes it's called the reactive electrode. Okay. Right. Moving on to the next one, which is basically what I just went through with you. Um, Here's a list of cations, and they are arranged according to the most difficult to be discharged to the easiest to be discharged. So you can look at potassium and silver. So you look at silver, it's got an E node of positive 0.80. That means it likes to be reduced. Whereas potassium, if you are looking for potassium, they are arranged alphabetically. So you go to K plus to go to K is negative 2.92. So you can see that potassium ion has a very high negative number, which means that it doesn't like to be reduced, but it likes to be oxidized. But of course, your cations will only go to cathode where reduction happens. Okay, only reduction happens at cathode. Okay, now we're going to do a little bit of exercise just to get you to be familiar with and so that you know how to use the data booklet. So imagine if you have 4 types of cations in your electrolyte, and then your cathode has to decide which one will it select to be discharged first. Okay, so how can you work that out is by looking at the E node values of each cation. Okay, so silver ion is Ag, and because they're arranged alphabetically, so it would be somewhere on top, at the top. E node is positive 0.80. Okay, zinc 2 plus, Z would be at the very bottom, which is on the next page. So you can see that zinc 2 plus here, it has a value of negative 0.76. Okay, so I will let you have a look at the data booklet first. Negative 0.76. Now, if you're wondering what these E node values are, these are voltage. Okay, these are in the number in voltage. So we will look at that later on in this topic. So for copper, it will be C. So you go through the list again. Now, if you notice, another thing that I want to point out, if you notice copper, since we know it's copper 2 plus, right? There are two half equations here, okay? And if I didn't give you the equation, you would question, which one do I use? Which value do I use? Now remember that electrolysis is always to extract or to give out elements. Okay, so in this case, you will choose the one that gives out an element, which is your copper plus. Okay, not Cu plus. So that means we have to take the value for this half equation, which is plus 0.34. Are you all doing okay so far? Okay.
Yes, miss.
Okay, thank you. PB would be under P. So again, PB2 plus to PB. So you have to read the data booklet carefully. It's not enough to read one side only. You have to read both sides. And that is negative 0.13. Okay, conveniently, they're already arranged to you from the most positive to the least positive. Okay, so because they are cations, we follow the rule that the most positive will be selected for discharge first. But in reality, actually, what happens is that it will discharge the Ag plus first. Once all the silver ions have finished in your electrolyte, then they move on to the copper ions. And then once they have discharged all the copper ions, they then move on to the Pb2 plus ions and finally the zinc 2 plus ions. Okay, so this is how you would answer them. If you have a foolscap paper, you can just write this down first, copy first, and this is on page 2 of your notes. Example 1, page 2. Okay, so that's for your positive ion, your cations. Your anions, which will go to the anode, which is the positive terminal. So this is the arrangement based on the most difficult to be discharged to the easiest to be discharged. Again, if we look at the data booklet, OH minus, so because they go to the anode where oxidation is happening, you would go through the product side, okay, because it's the reverse reaction. So if you look at OH minus here, OH minus will be oxidized into oxygen. So that's the element that you produce. Whereas sulfate, do we have sulfate here? So sulfate is not here, I believe. Yeah, because so you see the sulfate, they are most likely to go through reduction. So sulfate doesn't get oxidized. Okay. Okay, that's that. Now in the older syllabus, 2016 punya syllabus, the data booklet actually gives you a table of the E-note values that are arranged from the most positive to the least positive. Okay, so I feel like this is easier to look at because it will come in handy later on. Okay, so occasionally I will use this table, but you wouldn't be able to find it in your data booklet. Next is the relative concentration of the ions. Ions of higher concentration will be selectively discharged. Now, we haven't done the exercise on the selective discharge, but usually how we decide which ion being discharged is by writing down the formula, sodium chloride. Since it's a dilute solution, that means aqueous, a lot of water molecules in there. So there's the Na plus and the chloride ions. There's also the H plus from water and the OH minus from water. Okay, since it is a dilute solution means there's a lot of water. Okay, so we have to choose. First, we look at the cations between sodium and hydrogen ions. Hydrogen will be discharged, okay, depending on its easiness or its ease to be discharged. For your anion, if you look here, hydroxide will be easily discharged compared to chloride. So that means hydroxide ion will be chosen. So that's why you will observe oxygen gas being produced at the anode, right? Versus sodium chloride in concentrated solution. It does contain water, but at a small amount. So I will say high sodium ions and high chloride ions, low H plus and OH minus. Okay, so I will skip the cation because that's a little bit complicated to explain. But if you look at hydroxide and chloride, if we follow the rule or the guide, hydroxide should be discharged, right, to produce oxygen. However, because hydroxide ions contain lower amount, okay, or it has a lower concentration, that means chloride ion will be selected. So this is how concentration can affect the selectivity discharge. Okay, I'm sure this is nothing new for you. Have you done this before? If you use an aqueous solution and concentrated solution, yes. Okay, so it's basically a recap. But I think the one thing that's new for you is the E-note values, the electrode potential values. Okay. Right. So that's the same relative concentration. Last factor is the nature of the electrode. Okay. So usually inert electrodes are things like graphite, carbon. Graphite is sometimes called carbon. Platinum is an inert electrode, okay? So again, depending on the type of electrodes that you use, if it's inert, it doesn't affect your selectivity discharge. However, if it is reactive, usually reactive metals, if you use reactive metals as your electrode, then they will get involved in the oxidation process, okay? Right. So we go back to page 1 to do the example, just to check that you still know what to do and you know the process. So on page 1, question 1.1, example 1, you have to predict the identity of substance liberated during electrolysis. Write the ions present in the electrolyte. So usually what I did just now, I list down the possible ions, both cations and anions in the electrolyte solution. And then you have to write down the half equation occurring at the cathode and the anode. And then you have to write down the observation. Okay, hold on, yeah. Okay, right. So we have a dilute sulfuric acid. So H2SO4 aqueous, which means you would have H plus, you would have SO4 2 minus because there's water. You also have H plus from water and you have OH minus from water. Okay, since your cation, there's no other choice. Obviously, H plus will be selected for discharge. Okay, so what happens at cathode, which is your negative terminal, and I think you still remember red cat. That means at cathode, reduction occurs. And at anode, which is your positive terminal, oxidation occurs. Still remember this? Red cat and anox. Okay, so between sulfate and hydroxide ions, if you refer to this rule or the general guide just now, okay, OH minus will be discharged or selected over the sulfate ion. Okay, so that means it's the OH minus. So next we have to write down the equation. So at cathode, which is the negative terminal, H plus is being selected, and at anode, which is the positive terminal, OH minus is being selected. Now, with the data booklet, you actually don't have to memorize the equation. So let's have a look. H plus reduction. So if you are looking at H plus reduction, you should be looking at the left side. H plus here. H plus to go to H2. Okay, and because it's the reduction equation, you take the forward reaction. So to write that down, 2H plus 2 electrons to form H2 gas. So you don't have to worry about memorizing. Okay, hopefully they will give you this values in the exam. Sorry, this E-note values. As for OH minus, this time it's oxidation. Now oxidation is the reverse process. So you have to go to somewhere looking at the right side. So you see here OH minus, OH minus, but this one is producing HO2 minus, okay, or producing H2O. You don't want that. You want the OH minus that produces oxygen. Okay, so you have to be careful with choosing the equation. So you choose 4OH minus to give you O2 plus 2H2O plus 4 electrons. So 4OH minus to give you apa tadi? O2 2H2O. Okay, so you would observe bubbles of hydrogen at the cathode electrode, and you would also observe bubbles of oxygen at the anode electrode. Okay, what happens at the anode if carbon electrode is used instead? Now, carbon electrode is also inert. Therefore, same observation. Okay, the observation will be bubbles of gas on the cathode and as well as bubbles of gas, oxygen gas on the anode. Is this okay? Okay. So actually that is all for today.